Hello everyone, my name is Cuauhtémoc Daniel Suarez Ramirez and I'm going to present you about our paper Above and Beyond, a second-order optimizer for binarized neural networks. As you know, deep learning architecture uses lots of parameters, thousands and even millions, all of them in full precision, using 32 or 64 bits per value. It's a ton of memory. Also, inference requires complex operations, such as the convolution, multiplication, and so on. This might not mean a lot for normal devices, or for low power, low memory devices, this is not ideal, as we need to do some transformation of these kinds of architectures to fit into them. One of these operations is the pruning. Binarized neural networks are one solution, as we are using 1 bit per value and just 2 operations for the inference, or the convolution, the XNOR and the bit count operations. Still, we have two problems. One is the loss of accuracy, as we are using a much lower representation space, and the other one are the training algorithms, which are adaptations of full precision algorithms, such as gradient descent with an approximation of the sine derivative function. Our contribution is proposing a specialized optimizer for this kind of networks by just learning the binary weights, the -1 and the +1, by adapting the Adam optimizer. This means that we use the first and second row moment estimates of the gradients to decide when to flip the weight. There is another specialized optimizer called BOB, which only uses the first row moment estimate of the gradients. The main takeaways are that we have better accuracy than the state-of-the-art optimizers. This means compared to BOB and to the adaptations of the full precision methods tested in ImageNet using the BiRealNet and the XNORNet architectures. Also, we have two versions of the algorithm, an unbiased one and a biased one. One of them is more tunable and gets better results, and the other one is more stable and more resilient to changes in the hyperparameters, so it is easier to train. Also, there is a trade-off between the memory and the speed usage and the accuracy, as we are storing more parameters as we need to consider the second row moment estimate of the gradients. If you want to learn more about our paper, please see us at the posters. Thank you.